Welcome to This Explainer. Today, we're going on an absolute mind-bender of a journey. We're going to scale all the way up from human engineering to the absolute literal limits of the universe. If you've ever stared up at a towering skyscraper or a massive bridge and thought, man, how big can things actually get? Well, you're in exactly the right place. We're going to start with stuff we can touch, right here on the ground, push into wild theoretical futures, and finally look at the jaw-dropping megastructures the universe builds all by itself. So what is the absolute limit of what can be built, and how does it compare to the universe's own architecture? To really wrap our heads around this, we kind of need to anchor ourselves right here on Earth first. It's so incredibly easy to lose perspective when we start throwing around words like light years and galaxies. We need to figure out what massive means to us humans right now. Which brings us to Earth's largest megastructures, humanity's grounded giants. People love arguing over what the biggest man-made thing actually is. Are we counting a giant fenced-in nature reserve? What about a sprawling highway system? For us today, let's stick to pure, heavy-duty engineering marvels. When we're talking about usable volume, the Boeing Everett factory absolutely takes the crown. It's got an insane 13.3 million cubic meters of space. They literally had to build it just to assemble the 747 airliner, because, well, jumbo jets don't exactly fit in a standard garage. Right behind it are places like Tesla's Texas Gigafactory at 9.57 million cubic meters and Germany's Arium, which is wild. It was originally built for a giant airship and now houses an entire indoor tropical water park. But hold on, what happens when we switch our metric from volume to mass? On one hand, you've got the Boeing factory, a colossal, hollow shell enclosing 13.3 million cubic meters of air. But on the other hand, the Three Gorges Dam. This absolute beast required 16 million cubic meters of solid, heavy concrete. It perfectly highlights two entirely different vibes of megastructures, one built to hold things, and another built to literally hold back the massive forces of nature. Now, what if you want your megastructure to actually move? Look no further than the Bagger 288 bucket wheel excavator. It is literally bigger than most buildings. Weighing roughly 3 times more than other legendary excavators, this monster completely dominates the landscape. But it's not exactly winning any drag races. It trundles along at a blistering top speed of, wait for it, 2 kilometers per hour. Let's level up. The biggest structure in space, our orbital outpost. Taking our megastructures into the vacuum of space brings a whole new set of headaches. You can't exactly pour concrete in orbit. The International Space Station, this 356-foot, 925,000-pound lab, had to be constructed piece by piece in microgravity. It kicked off with the Russian Zarya module back in 1998, and by 2000, astronauts moved in full-time. Thanks to a historic team-up of 15 different nations, they meticulously pieced together modules and solar panels the size of a football field, wrapping up the main construction in 2011. To really put yourself in their space boots, imagine floating through a lab that has more livable room than a conventional 6-bedroom house. Seriously, it's got 2 bathrooms, gym equipment so your muscles don't turn to mush in zero-G, and the cupola, this incredible 360-degree bay window looking down at Earth. Astronauts actually compare the total pressurized volume to the inside of a Boeing 747. But the ISS is more than just floating metal. It's zipping around the planet at 17,500 miles per hour, doing a full orbit every 90 minutes. It's seen some crazy endurance records, like a U.S. astronaut staying up for 371 consecutive days, and the longest female flight at 328 days. But it's also got a fun, wonderfully human side. Remember back in 2016? Astronaut Mark Kelly literally smuggled a full gorilla suit on board and chased a colleague through the modules? Classic. All right, let's push the envelope here. Theoretical galaxy-sized worlds, pushing physics to the limit. So what happens to our sense of scale when we max out the laws of physics? Enter the Birch Planet. Conceived by Paul Birch, this is a theoretical megastructure built entirely around a supermassive black hole, specifically one like the 4 million solar mass beast sitting in the center of our Milky Way. It sounds like pure sci-fi, I know, but it's actually deeply rooted in known theoretical physics. The numbers here are going to break your brain. An artificial shell around our galaxy's central black hole would give us 1.4 trillion times the living area of Earth. 1.4 trillion. Think about that for a second. That is more living space than if you took every single rocky planet in the entire galaxy and perfectly terraformed them. And the crazy part? That's just the starting point. If we go to the extreme upper limit, like taking a whole galaxy's worth of surplus matter and feeding it into the black hole for power, we could theoretically build a world almost a light year across. It would have normal Earth gravity, but offer a billion times Earth's living space. That's likely more habitable space than every single planet in the entire observable universe combined, all on one single engineered shell. Absolutely insane.
Okay, time for the ultimate zoom out. Quipu, the cosmic giant, the universe's natural architecture. We've really stretched our human imaginations to the breaking point with theoretical birch planets. But what about the actual physical reality of our universe? Turns out the cosmos itself is the ultimate architect. Up to 800 million light-years away sits Quipu. It's a colossal filament containing 68 galaxy clusters. It stretches an incomprehensible 1.3 billion light-years across and holds the mass of some 200 quadrillion stars. Researchers named it Quipu after the knotted string recording devices used by the ancient Incas, because this massive string of galaxy clusters perfectly resembles those ancient knotted threads.
And Quipu isn't even flying solo. It's one of 5 major superstructures that completely dominate our local universe. Together, these 5 giants hold 45% of all local galaxy clusters, 30% of the galaxies, and 25% of all matter in the region. They are so incredibly massive that their gravity actually warps the cosmic microwave background, that relic heat left over from the Big Bang. Now you might be asking yourself, how did we only just recently map this out? Well, astronomers used an X-ray survey across most of the sky, but they actively had to peer around something called the zone of avoidance. Basically, the thick dust and stars of our own Milky Way literally get in the way and block our view of the deep universe. Quipu just so happens to stretch right behind this dark zone and pop out the other side. But here's a really profound realization. Despite its majestic 1.3 billion light-year size, Quipu is doomed. It's a transient cosmic configuration. Because the universe is expanding, that immense expansion will eventually overpower Quipu's gravity. It's going to break apart into smaller, collapsing cosmic units.
Which leaves us with one final, awe-inspiring question. We've gone from a massive Boeing factory here on Earth to an orbiting space station, hypothesized about galaxy-sized shells, and discovered a 1.3 billion light-year-long string of galaxies. As Quipu inevitably fragments, what other mind-bending architectural giants are waiting out there in the dark for us to discover? As we find new ways to look past that zone of avoidance, the true scale of our cosmic neighborhood is only just starting to reveal itself. Thanks for joining me on this explainer, and hey, keep looking up.